So in previous class, we had started exercise 12.2 of the applications of trigonometry. And already we had completed 3 problems in that exercise. Now, shall we start the 4th problem? Okay. Yes. The 4th problem is, from the top of a building, the angle of elevation of the top of a cell tower is 60 degrees. And the angle of depression to its foot is 45 degrees. If distance of the building from the tower is 7 meters, then find the height of the tower. That's the question. So watch the problem carefully and imagine the scene. So this is the base, there is the ground, and it is a building, and also a cell tower is there. And now it is given that the angle of elevation of the top of a cell tower from the top of a building is 60 degrees like this. This is the horizontal line. This dotted line is horizontal line. Here the angle is 60 degrees. The angle of elevation is 60 degrees. And the angle of depression of the foot of cell tower is 45 degrees. And the distance between the building from the tower is 7 meters. That is the distance between the feet of both building and tower is 7 meters. That is the data. Now draw the figure for this data. So here it's base, and first one is building, second one is cell tower. So this is a horizontal line. Now the angle of elevation from the top of the building is 60 degrees, and the angle of depression from the top of the building is 45 degrees. Okay. Now the question is, what is the height of the tower? Here let's take it as A, B, C, D, E. Okay. Given BD is equal to 7 meters. BD means distance of the building from the tower. Here it is 90 degrees, both are. Now let AB is height of the building, CD is height of the tower, AE is horizontal line. Given the measurements are, angle CAE is 60 degrees and angle DAE is 45 degrees. But here AE is horizontal line, so AE is equal to BD, so that AE is equal to BD is equal to 7 meters. Here AE parallel to BD. Okay, as AE is horizontal line, AE is parallel to BD, and if AD is transversal, the alternate angles are equal, so that angle ADB is equal to angle 45. Okay. Now from triangle ABD, first of all, what we have to find here? Height of the tower, total CD we have to find. That is the distance CD that we have to find here. Okay. So directly we cannot find distance CD. First we have to find the distance ED, and then after CE, and then by adding both CE and ED, then only we get the height of the tower. We know that ED is equal to AB here. So first find AB, which is equal to DE. Then after find CE. Then by adding CE and ED, we get the height of the tower. So take from triangle ABD, tan D is equal to AB by BD. So tan 45 is equal to AB by 7. That is 1 is equal to AB by 7, giving AB is equal to 7 meters. Okay. As AB is equal to 7 meters, ED is also equal to 7 meters. Now take triangle ACE. From triangle ACE, tan A is equal to opposite by adjacent. That is CE by AE. But we know that AE is equal to BD. Okay. Which is equal to 7. So A is equal to 60 degrees. AE is equal to 7. Tan 60 is equal to CE by 7. That is root 3 is equal to CE by 7. C is equal to 7 root 3. Now the height of the tower CD is sum of CE and DE. That is 7 root 3 plus 7. So 7 into, by taking 7 common, 7 into root 3 plus 1. And we know that root 3 is equal to 1.732. So now 7 into 2.732, which is equal to 19.124, which is the height of the tower. Therefore, the height of the tower is 19.124 meters. Okay. So the next problem is, fifth one is, a wire of length 18 meter had been tied with electric pole at an angle of 30 degrees with the ground. Because it was covering a long distance, it was cut and tied an angle of elevation 60 degrees with the ground. How much length of the wire was cut? Okay. So this is the base, this is ground, and an electric pole erected by tied with a wire of length 18 meters, which is making an angle of elevation 30 degrees with the base. Okay. So it's making a 30 degrees angle with the base. But as it was covering a long distance, the wire was cut and then tied such that the angle of elevation is 60 degrees, like this. Now it is asking that how much length of the wire was cut. Okay. At first, the length of the wire is 18 meters, and we don't know the length of the wire after cutting the wire. So if we know the length of the wire after cutting, then the difference between both the wires is the length of the wire was cut. Okay. So we have to find here the length of the wire after cutting. So this is the figure. Okay. A, B, C, D, and the length of the wire at first is 18 meters. Take the distance between C and D is as X and AB as H. You know that the angle here is 90 degrees. Now let AB be height of the pole be H meters. C and D are the points where the wire was tied on the ground. Now CD is taken as X meters. Given angle ADB is equal to 60 degrees, angle ACB equal to 30 degrees, angle ADB is 30 degrees, angle ACB is 60 degrees, and AD is equal to 18. That is 18 meters. Now we have to find AD minus AC. How much wire was cut? That is AD minus AC. We know AD. Now we need to find AC. So from the figure, first we find BC. After that, we find the distance AC. Okay. So from triangle ABD, sin D is equal to AB by BD. That is sin 30 is equal to H by 18. H is equal to 18 by 2. That is 9 meters. So that is we are finding first H. H is equal to 9 meters. Now from triangle ABC, sin C equal to AB by AC. Sin 60 is equal to H by AC. That is root 3 by 2 is equal to 9 by AC. Because we got H is equal to 9 here. Now AC is equal to 9 to the 18 by root 3. So we can write it as 6 into 3 and AC is equal to 6 root 3. Now AC is equal to, by substituting root 3 is equal to 0.732, we get 10.392 meters. This is the length of AC, but we need the length of the wire was cut. So the length of the wire was cut is AD minus AC. So 18 minus 10.392, which is equal to 7.608 meters. Okay. Okay, students. Next, the next problem is sixth problem. The angle of elevation of the top of a building from the foot of the tower is 30 degrees. And the angle of elevation of the top of the tower from the foot of the building is 60 degrees. If the tower is 30 meters high, find the height of the building. So this is the scene. There is a building and a tower. The angle of elevation of the top of the building is 30 degrees. And the angle of elevation of the top of the tower is 60 degrees. If the tower is 30 meters high, what is the height of the building? That is the question. So draw the figure for given scene. Okay. So A, B, C, D, and the height of the tower is 30. Now write that A, B, B height of the building, B, C, C, D, B the height of the tower, which is equal to 30 meters, and given angle ADB is equal to 30 degrees, angle CBD is equal to 60 degrees. So here we have to find the height of the building, that is AB. So to know the value of AB, first we have to find BD, which is the common side in both ABD and BCD. So let us find BD from triangle BCD. Okay, from triangle BCD, tan B is equal to CD by BD. That is tan 60 equal to 30 by BD. So from this we can write the root 3 is equal to 30 by BD. BD is equal to 30 by root 3. That is 10 into 3 by root 3, which is equal to 10 root 3. That is BD. Now take triangle ABD. From triangle ABD, tan D is equal to AB by BD, opposite by adjacent. That is tan 30 is equal to AB by BD. We know that BD is equal to 10 root 3. Now 1 by root 3 equal to AB by 10 root 3. So AB is equal to 10 root 3 by 3, which is equal to 10. So therefore height of the building is 10 meters. Okay. Now let us see the next problem. Two poles of equal heights are standing opposite to each other on either side of the road, which is 120 feet wide. From a point between them on the road, the angles of elevation of the poles are 60 degrees and 30 degrees respectively. Find the height of the poles and the distance of the point from the poles. That's the question. So here is the road, and two poles of equal heights are stand on either side of the road. The road is 120 feet wide. Now, from a point between them on the road, the angles of elevations are 30 degrees and 60 degrees, like this. Now, it is asking that what is the height of the poles and the distance of the point, that is observation point from the poles. Okay, so draw the picture. So poles are of equal height here. So A, B, C, D are the heights of the poles. E is the point of observation. And wide of the road is 120 feet. The width of the road is 120 feet. Now, let AB and CD are poles of equal height. E is the point of observation. BD is width of the road. Given angle AEB is equal to 60 degrees, angle CED is equal to 30 degrees. So we don't know the distance BE here. We know BD is equal to 120, but don't know the value of BE. So let BE is equal to X feet. Now, then DE is equal to difference of BD and BE, that is 120 minus X feet. Now I'm writing here BE is equal to X and ED is equal to 120 minus X. From triangle ABE, find AB, and from triangle CDE, find CD, and by equalizing both AB and CD, we get the answer, that is X. Okay, so tan E is equal to AB by BE, that is tan 60 is equal to AB by X. So root 3 is equal to AB by X. AB is equal to X root 3. And now from triangle CDE, tan E is equal to CD by DE. That is tan 30 is equal to CD by 120 minus X. So 1 by root 3 is equal to CD by 120 minus X. CD is equal to 120 minus X by root 3. But we know AB is equal to CD because they are of equal height. So now substituting both AB and CD values, and by simplifying, we get 4x is equal to 120 and x is equal to 30. And what is x here? The distance between B and E. Now, the height of the pole is AB equal to, we have here, AB is equal to x root 3. So, is equal to x root 3, that is 30 into root 3 feet. Height of the pole is 30 into root 3 feet. And BE is equal to 30 feet. DE is equal to 120 minus x, that is 120 minus 30, 90 feet. So the distances of the point from poles are 30 feet and 90 feet. B is 30 feet, D is equal to 90 feet. That is the position of the point of observation here. Okay. Okay, students, that's all for today. And in next chapter, we are going to complete this chapter, applications of trigonometry. In next class, we are going to complete. So don't miss. See you in next class. Bye.